This video is on an introduction to organic chemistry and hydrocarbons. Organic chemistry is the study of organic compounds. Organic compounds are compounds that contain one or more C and H atoms. So anytime we're using organic chemistry, we're going to be looking at carbon a lot. 95% of all the compounds out there are organic. And there's a lot of biological compounds, such as the foods that we eat, the carbohydrates, the proteins, the lipids, our DNA, our RNA, different hormones, the fuels that we use, natural gas, propane, gasoline. These are all made up of organic compounds. Consumer products, styrofoam, plastics, etc. You can read down here. All of these are made up of organic compounds. Something essential in organic chemistry is something called a hydrocarbon. A hydrocarbon is a compound that contains only carbons and hydrogens. So what we saw before when we were doing Lewis structures is that carbon can form 4 bonds. And I would say 99% of the time, a majority of the time, carbon will form 4 bonds. And these bonds can be in any different ways. It can be 4 single bonds, it can be 2 double bonds, it can be a triple bond and a single bond. The 4 bonds on the carbon atom can be to other carbon atoms, it can be to hydrogen atoms, or it can be to other nonmetals as listed there. If carbon is bonded with only single bonds, it has 4 single bonds, that is something called an alkane or a cycloalkane. The prefix cyclo will make it a cyclic compound. More with that to come later on. If carbon has double bonds in it, whether it's 1 double bond and then 2 single bonds, or if it's 2 double bonds, that is called an alkene and an aromatic hydrocarbon. We will see our aromatic hydrocarbons are in a lot of things that give off an aroma, such as vanilla. If carbon has a triple bond and a single bond, that is called an alkyne with a Y. So 3 different types. We have alkanes, alkenes, and alkynes, and it's very imperative that you know the difference between the 3. Looking a little bit closer at them, notice for alkanes, each carbon is surrounded by 4 bonds. In this case, there are 4 single bonds around each of the carbons. That's why it is an alkane. We say that these carbons are saturated. These are saturated carbons. Your alkenes, notice that at least one of your carbons, in this case 2, have a double bond. Your alkynes, notice you have a triple bond here. And then your aromatic hydrocarbon, a lot of times it'll be in a ring formation. So here's an example where you have 6 carbons, so it forms a hexagon looking figure. If you would have 5 carbons, you would form a pentagon looking figure, 4 would be a square, 3 would be a triangle, so on and so forth. Notice the alternating single and double bonds here. So you have a double and then a single, double, and a single. The reason you can't have back-to-back doubles here is because then if you counted the bonds on this carbon, there would be 5 bonds there, which would be 10 electrons. Carbon can only have 4 bonds or 8 electrons to satisfy the octet rule. So that is why you need alternating single and double bonds. Your hydrocarbons, and again, hydrocarbon is just compounds containing C and H only. They're all nonpolar. And the reason they are nonpolar is because the symmetry in them cancels. And your alkanes anyways. So the only intermolecular force they have are your London dispersion forces. Remember, for dipole, it needs to be a polar molecule. These have lower melting points and boiling points than polar substances, and they are immiscible with aqueous solutions. Immiscible means it forms more than one layer, like oil and vinegar, for example. And we call this a hydrophobic effect. Hydro means water, so your aqueous is water, and then phobic is fear of. So it doesn't want to mix with the water. It forms two layers. So right here, we're just going to classify each as organic and inorganic, and then if it's a hydrocarbon or not. So it would be a good time to pause the video and then try it on your own. So for A, this is organic. B, this is inorganic. C is inorganic. D is organic, and this is a hydrocarbon because it only has C's and H's. E is organic. Water is inorganic. Your fats, your carbs, all that stuff is organic. And CO2 is inorganic.